Good morning, students. Today we'll be starting with exercise 1D. Alright, so before starting with exercise 1D, we should know what are irrational numbers. Alright, so irrational numbers. So the definition of irrational numbers: a number which cannot be expressed in the form P by Q. Alright, where P and Q being integers and Q is not equal to 0. Also, the other definition of irrational numbers are the numbers which can neither, a number which can neither be expressed as a terminating nor a repeating decimal number. Alright, for example, now the points to be noted. Alright, so from this point you can understand more about what is a rational number. So number one is non-terminating, non-repeating are irrational numbers. For example, numbers which are non-repeating or non-terminating, like 0, 0, 2, 0, 0, 2, 0, 0, 0, 2, 0, 0, 0, 0, 2, and so on and so forth. So in this case, we can see that the numbers are not repeating. For example, we have 0, 2, then after that we have 2 zeros and 2 excuse me, again we have 3 zeros and 2, then again we have 4 zeros and 2, and then 5 zeros and 2. So in this case, you can see that the numbers are non-repeating. Alright, and also these numbers do not have an ending. So these type of numbers are called irrational numbers. For example, another example, we can take 0.13, alright, and then 1 1. See, 1, it is not repeating. In this case, there are 2 1 and then 3. Then again we have 3 1s and then 3, and then 4 1s and then 3, and so on and so forth. So these are examples of irrational numbers. Alright, now condition number 2, not a perfect square. So example of perfect square, for example, irrational numbers which are not perfect square will be 2. Alright, so root 2, alright, so the value of root 2 will be 1.43, so on and so forth. Alright, in this case it shows that the number is non-repeating, non-terminating, so that's why root 2 is an irrational number. Root 3 also will be 1.71 something. Alright, so in this case also the number is non-repeating, non-terminating. So in this case also we can say that root 3 is is an irrational number. So in this case, root 4. So what is the square root of 4? The square root of 4 will be 2. So in this case, 2 is a perfect square. So in this case, root 4 is not a rational number. Alright, in this case, root 2 is not a rational number. Alright, so what about root 5? Root 5, so just let me check. Root 5, we can use a calculator. Alright, so in this case, root 5, so the value of root 5, as you can see, will be 2.23609. You can see that it is non-repeating and non-terminating. So in this case, root 5 is also an irrational number. All right, so this one will be 2.236, so on and so forth. So in this case, root 5 is also an example of an irrational number. All right, so this is all about irrational numbers. So I hope it is clear. So let us start with exercise 1D. All right, so for question number 1, you can do it by yourself. Define an irrational number. How does it differ from a rational number? So question number 1, you can do it by yourself. So let us start with question number 2. Examine whether the following numbers are rational or irrational. All right, so exercise 1D, question number 2. So we have to find out whether these numbers are irrational or rational. So the first one is root 5. So we know that root 5 is not a perfect square, so therefore we can say that root 5 is an irrational number. All right, so here you will write since root 5 is not a perfect square, so therefore root 5 is an irrational number. All right, because we have showed that the value of root 5 will be 2.6 something. All right, it is a non-repeating, non-terminating, so that's why root 5 is an irrational number. All right, now for number 2 is root 9. So in this case, the square root of 9 will be 3. All right, so therefore you write here since root 9 is a perfect square. All right, so that is root 9, the square root of 9 will be 3. So therefore root 9 is not an irrational number. All right, so very simple. Again for number 3, so number 3 we have 45. All right, so the square root of 45 so in this case we have so you write here we have root of 45 will be 3 to the power square into 5. All right, so here we can just check it out. 3 1 will be 3 5, then 3 5 will be 15. So in this case it will be 3 root to the power 5. All right, so in this case also we can see that the product of a rational number and irrational number is irrational, so therefore root 45 will be an irrational number. So here you can just simply write now since 3 root 5 is a product. All right, so here we multiply 3 into root 5, that's why it's called product. So since 3 by root 5 is a product of a rational, so in this case the rational number is 3 and the irrational number will be root 5, is a product of a rational and an irrational number. So therefore root 45 is an irrational number. All right, so in this case, if you come across this type of situation where a rational is multiplied with an irrational number, so therefore it will always be an irrational number. All right, now question number 4, exercise 1D. 5 minus root to the power root 2, and then we have 5 plus root 2. So in this case we will be using the formula a minus b, a plus b. So we will be getting a square minus b square. So we will use this identity to solve this one, and we will find out whether it is a rational or irrational number. So answer, you write we have 5 minus root 2, 5 plus root 2. So this is a, this is b, this is a, this is b. Using the identity, we will get 5 to the power square minus root 2 to the power square. So in this case it will be 25, and root 2 to the power square, this square in this case the power the square root will vanish and we will be left with 2. So in this case it will be 23, which is a rational number. So therefore you will write here, therefore it is not an irrational number. All right, so now number 5, we have root 3 plus root 2 to the power square. So in this case it is the identity will be a plus b whole thing square. It will be a square plus b square plus 2ab. So we will use this formula to solve for this one. So you write we have root 3 plus root 2 whole thing to the power square is equal to a square plus b square. So this will be a and this will be b, plus 2 into root 3 into root 2. So in this case it will be root 3 to the power square will be 3, root 2 to the power square it will be 2, plus 2 into 3 into 2. So it will be in this case 3 plus 2 will be 5, plus 2 into 2 into 3 will be 6. So in this case root 6 is an irrational number. So in this case we can say that this is an irrational number. All right. So here you will write this is an irrational number. All right, and the last one, root 6 minus 2. So in this case we know that root 6 is also an irrational number. So you write here we have root 6 minus 2. All right, so in this case you will write, since root 6 is irrational, all right, so therefore product of rational, also here we can write the difference, of an irrational number, of an irrational and rational number is irrational. All right, so therefore root 6 minus 2 is an irrational number. All right, so in this case also we can say that the product of rational and irrational will be irrational, and the sum of a rational plus with an irrational will also be an irrational. So this will be your answer. Next we will start with question number 2, number 1. So let us see whether root 9 by 27 is a rational number or irrational. All right, so I will just show only number B, number 1, and then number 2 and number 3 you can do it by yourself. Also question number C, you can do it by yourself. All right, very simple. So let me just show exercise 1D number 1. So in this case answer, so you write we have 9 by 27. So in this case 3 will be 9 and 3 9, then 3 1 3 3. So in this case we are having 1 by 3. All right, so what we will do next is we will split them up. So the square root of 1 will be 1, and in this case it will be root 3. All right, so as per the rules of mathematics, root 3 cannot be in the place of denominator. It should always be in the place of numerator. So what we'll do in this case is we have to rationalize. All right, so we shall rationalize in such a way that both numerator and denominator will be multiplied by root 3. All right, so this is called rationalizing the denominator. All right, rationalizing the denominator. So in this case we have root 3 by, so root 3 into root 3 we will be left with 3. All right, so in this case we know that root 3 is an irrational number. So here we will write since root 3 is an irrational number, so therefore any rational number, so therefore you write any irrational number, all right, divided by a rational is an irrational number. All right, so therefore 9 by 27 is an irrational number. So this will be your answer. Next we will be doing question number 3. So in the following equation, which variable represent irrational numbers? All right, I will just show number 1, and then the rest you can try it down by yourself. All right, so number 1 we have x squared is equal to 3. So in this case when we remove the power square, so what will happen to 3? Square root. All right, there will be a square root for 3. Now we know that root 3 is an irrational number. So since root 3 is an irrational number, so therefore you will write here x represent an irrational number. All right, so very simple. So according to your syllabus, lab 2 is not required. So and question number 4 also will not be doing. So you finish question number 3 Still sub question number 6. So that's all for exercise 1D.